Okay, in this section we are going to look at applying the Pythagorean relationship. So problem solving with word problems, with different variety of issues that come up to do with the Pythagorean relationship, and you're going to want to practice all of the word problems because they're all unique to each other. So there's two ways here that the Pythagorean relationship can be used. So the Pythagorean relationship can be used to, one thing it can be used to do is determine distances that are impossible to measure. So if you look at the triangle that I have drawn here, you'll notice that those lengths, if you think about the units, those lengths are incredibly large. So one length is 500 meters, the other length is 1200 meters, and we're trying to find the hypotenuse. So draw a right angle in there. It's determining the length of D. So there's no way I have a tape measure, even if I went outside and went 500 meters and 1200 meters to find the diagonal, I wouldn't have a tape measure long enough to do that. So we can use the Pythagorean relationship to solve questions that require things that are impossible to measure. So in this case, you can use numbers, you can use a picture. I'm going to use the diagram, or at least give you an idea of the diagram here. And let me just create some space, and you might want to pause this to copy it down if you'd like to. But the idea is, we know from the Pythagorean relationship, again this has been done several times, just not with such large numbers, that the areas of the two small squares adds up to the area of the large square. So in this particular case, step number one would be to do 500 times 500, and that's going to be 250,000 meters squared. We can also do 1200 times 1200, and you are going to want to try this on your own calculator as I'm doing this. It's always better if you pause this video and try some things on your own. Otherwise you're just watching and not really participating in your own learning. That's going to be 1,440,000 meters squared. This largest area is going to be the sum of those two. So 1,440,000 plus 250,000, and that's going to be 1,690,000 meters squared. So if you want to find this length, you should remember that you take the square root of 1,690,000, and that's going to give you, let's just find it out, the square root of 1,690,000 is 1,300, and that makes sense. Again, it's always very important in these sections to see if your answer makes sense. So if the two perpendicular distances are 500 and 1200 meters, it makes sense that the diagonal hypotenuse would be 1300 meters. All right, the last thing in this particular chapter and in this section is we can also use the Pythagorean relationship to show if a triangle is a right triangle. So we can use distances and lengths to find out if a triangle is a right triangle. So the question here is the triangle below a right triangle? So this triangle, we don't know if it's a right triangle, but we're going to investigate to see if it is. So if it is a right triangle, the idea, in this case I'm not going to draw the squares on the sides, but if it is, we know that a squared plus b squared equals c squared. So if I do 5 times 5, the a squared is 25 centimeters squared. If I do 6 times 6, the b squared is 36 centimeters squared. And if I do 8 times 8, that's the larger square, that is 64 centimeters squared. So if this is a right triangle, then the two smaller areas, the 25 plus the 36, would equal up to the 64. And if they don't, then it's not a right triangle. And 25 plus 36 is actually equal to 61 in this case. So since 61 does not equal 64, the answer is going to be no.